Okay, so that's us. So it's over to me. So good evening, everyone, and a warm welcome. This is the third event in our series to date, which we've christened now Passivhaus Live. So my name is Barry McCarn, for anybody who doesn't know me, and I'm the current chair of the Passivhaus Association of Ireland. The sun has decided to just shine so eloquently in my face with perfect timing, but we'll continue on. So really, I'm just providing a bit of context before we kick off proceedings this evening, and it's really, in essence, it's just to give you a little bit of an overview of the Passivhaus Association of Ireland, which is 10 years old now, and we've been the body representing Passivhaus on the island of Ireland during those years, promoting the benefits really of really good energy-based design based on the Passivhaus principles to the construction sector in Ireland. Passivhaus design is the proven quality assured route to delivering high performance buildings, and that is so pertinent now against the backdrop of a declared climate emergency by our own government, now with the bill put into law yesterday, an increasing requirement to deliver low carbon buildings against the climate change imperative, the fresh emerging context of the pandemic and the importance of ventilation in buildings. So it's against all of that backdrop that we're here tonight to share our stories and to spread the word really as it goes. So it's really the mission of the Passivhaus Association of Ireland to promote, educate and facilitate the growing demand that there is for the Passivhaus standard as well. And then to continue on, we, the Passivhaus Association of Ireland, are part of a wider network. We're an affiliate with the International Passivhaus Association. So again, if you like the content that is there, and if you're watching the video retrospectively, or you're here tonight attending, we'd like to invite you to have a look at joining our membership. It's quite modest. And if you want to learn more about the community and get involved in our events, that's a really good starting point. It really is a very vibrant body with really good people working at the progressive end of this sector. Okay, so tonight really builds upon the first two events, which we think have gone really well. Really, I think that the essence of why they've gone so well is because it's a personal story, a personal journey, and tonight continues in that vein. Okay, so just for those who maybe are joining in, or somebody that's maybe watching this again retrospectively who's not familiar with the format, what is going to happen is we're going to have a guest speaker now, and Simon will introduce those in a moment, followed by a brief Q&A, very brief, and then after that we'll have a breakout session in which we'll be virtually chucked into rooms separately, and that will last for about 5 or 6 minutes. It's really to get us out of our comfort zone and get talking, so don't shy away from that session. It'll be really interesting to see who you meet in the room. So without further ado, I think it's over to Simon now, who's going to introduce to us who our guest speaker is tonight.
Thanks, Barry. Yes, so tonight we have John Moorhead. Glad to welcome John to the event, who's going to be talking on Passivhaus performance in a temperate coastal climate. So his 10 years plus of learning. John is director of Wainmoor Architects Limited, a Cork-based architectural firm synonymous with the delivery of ecologically friendly and energy efficient architecture. He also holds qualifications in project management, thermography, and has been a BER assessor for both domestic and non-domestic buildings since 2007. John was one of the first tranches of certified European Passivhaus designers back in 2010. And I think, as you'll hear tonight, his journey started before that, but he has delivered a number of fully certified Passivhaus projects, including the first project to achieve the gold HPI standard awarded by the Irish Green Building Council. John is a board member of PHAI. He's a member of the RIA Housing Committee and external examiner for TU Dublin, as well as being active in a number of research areas in climate and carbon in construction. So welcome, John, to the event, and I'll hand over to you.
How's that then? Simon, thank you very much for your very kind introduction. Yeah, I'm going to try and give you a story rather than any technical details in relation to projects we've been working on and how we got embroiled in the whole Passivhaus scene back from 2009 to 2010, and really don't know any other way of producing buildings since. So I've got a lot of slides. I'm going to rip through some of them, and maybe we could discuss anything you want to raise afterwards if we need to. So I'm going to head on here. Need to close you lot though, because you're covering my notes. There you go. I've shown this slide before, and I think it's interesting. You know, although we're interested in Passivhaus and delivering high performance buildings, we mustn't lose sight of their primary function, which is really, you know, habitation, shelter, and comfort. And as architects, generally with like us from Bolton Street, anyway, Bachelor of Architectural Science degree, I firmly believe science should always influence our design decisions. This is a picking of the beehive huts occupied by the 7th century monks on the southern side of Skellig Wickle. And if you haven't been there, I really would suggest you get down there. They've high thermal mass, they're stone. They really have good solar access, not obviously during the fog in this particular occasion. They're very resilient form. They don't lose pitched roofs, etc. And I believe they were lined in mud for airtightness. Moving from that to this, top left there in the corner, you'll see a picture of a rather sad looking, it looked like a prefab. It was a flat roofed house that we came across in '96 and did some intermediate work, replacing single glazed windows and some cosmetic work, and also kept the flat roof. It's like a incubation unit up at the top there, that black box in the center, where we have a water tank in the flat roof, entrapped and embroiled and encapsulated by a Paralon type roofing membrane, ensuring that condensation really happens. I think my eyes opened when I opened the lid on that, and I really began to understand how flat roofs were failing. It became quite an experiment. Anyway, we outgrew the house and we need to do something on top. Now, this was been about in 2002, so excuse the graphics from 20 years ago. But that's what we decided to do. We decided to go perpendicular to the house and leave the flat roof, use it as a vapor control layer, and build this entirely independently of the main house, just held in 4 places or 5 places. So it's cantilever structure. Sent drawings away to a really good firm in Austria, Unterlager, and worked with crowds in Galway, Natural Timber Construction, and the Austrians, and this arrived. And it was really interesting. We were trying to get better light penetration into the building, and also obviously look at the whole thermal performance of the building. The Austrian companies themselves were very advanced, very knowledgeable, introduced me to the whole, many hygrothermal principles. Airtightness, as you can see, even though these windows, which were installed prior to arriving, all airtight sealed. OSB was the airtight layer on the interior. And we actually had this building assembled in 4 days. Went up really quickly. We built a little pond while we were at it for the kids. A big boss came back over from Sweden during the second half of the build. Literally the kids and family went away, and 8 days later this was up and roofed and guttered. Haven't managed to achieve it ever since, but it was really quick. You can see the insulation there straight down over the VCL, which is the original roofing membrane, on the single story element, and then the perpendicular 2-story element, which is timbered glulam. Trusses there were insulated from inside with cos battens and then Proclima membranes. I think I might have a picture of that. And then here you see sarking boards, the walls already prepared for larch cladding, which we did ourselves, and the aprons in for the zinc roofing on basically the hairy boards which support the zinc, and that's still the way we do ventilated zinc roofs. There's the zinc going on. We had a press on site, and we had a really, this is the crew, myself fell in with them, and this is the main crew from Galway in Austria. And as I say, we had the building in and roofed and guttered in 8 days. And we have our local crew fitting out the interior afterwards, and that's the original AVCL Proclima. But you can't deliver any of these buildings, as we all know, in Passivhaus without a really good team, and all these guys were added value to the whole process. That's it finished. You can see quite a transformation. That would have been, say, about 3 years maybe after it was built, 4 maybe. And here we are 20 years on. The larch windows still remain as they were, unfinished. The larch is greyed off like the architect. And the timber windows down below, which I didn't mention earlier, which were installed in 1996, we've painted those since. We found in the original building, there was no overhangs, and those timber windows really did get a hammering. So then moving on to around 2003, we were doing an infill project for someone. It was again, it was local. It was on the coast in the estuaries in Cork, not that exposed. It had northerly view to the estuary and southerly view into the original river embankment. So we were trying to pull sun in from the back. So it's very sheltered. With concerns because of the amount of sun we were trying to pull in from the back that we might get overheating at the time, and we introduced stack effect into the design. So modest house, about 140 square meters. There's our stack effect ventilation built in. And you can see it just dumps on the outside. And then we pull light into the northerly side of the house, which is overlooking the estuary where there's a lot of activity. High volume spaces we were beginning to understand really worked in buildings that were already quite airtight. The envelopes were airtight and the timber was moisture permeable. It allowed variation in temperatures and solar access during a day. As you all know, we have 4 seasons in the one day here. It allowed that to dissipate and distribute. So the watts per square meter became very important, the heat load and how that was being addressed and dissipated. Here's the back of the house, a totally different aspect. As you can see the high level ventilation. During COVID, that house, which is naturally aspirated and naturally stack aspirated, never went over 600 ppm, which was remarkable. We ran a deep 4 calculation on it the other day, and as it is, without any PV, an A3 rating, CPC of 0.48 and EPC of 0.426, with a heating load under Passivhaus about 17.5. So it wasn't 10, but it wasn't bad. Not again for say 2005. Another one on more or less simultaneously. This is a very long house, east-west access, facing south, looking straight out the harbour, very exposed. Many a rock ends up in the lawn there. Again, naturally aspirated, naturally stack ventilated. We generally try to take in more than we need energy-wise and dump it in the summer to provide cooling, where you can pull air across the cooler surfaces of the water into the house. Works very well. That had a solar thermal array and a very large thermal store. I can't remember, it was 800 or 1100 litres underfloor heating system, and it was one of those houses that was tested in the period of winters that we had, consecutive winters which were really cold, where we had temperatures, down into the -10s, and the client was reported to be running around in their shorts and t-shirts during that time. Again, the airtight envelope was becoming very popular within our office, in that we were guaranteeing comfort and our energy loads were dropping, and obviously cost for heating dropping like a stone as a result. So it's very mild on the coast, but it can be very windy, and it's like wearing an Aran jumper. It can run right through you. Similar picky from the rear, from the wood side, and again you can see it's mild. naturally aspirated, good overhangs, create good shelter and reduce airflow in the building with a bit of articulation. Just show this picture from interest perspective. On the left, you have the southerly aspect with very warm sun, and on the right, the northerly aspect with very cool blue light. That wall is actually continual. You can see the beam running across the top, but it's interesting to see the different colors of light. Again, stack ventilation, bringing air from below up to the upper levels. Next one we have here is many of you might recognize. This was a project we tendered, and we were actually on site in 2009. Our ability to predict energy performance took a huge leap forward when we were lucky enough to attend the Strathclyde University for the first Passivhaus course rollout. Up to then, our sort of holistic approach, incorporating passive solar principles and stack ventilation, would have guided how we operated, and it was more from touch and feel rather than numerics. It was fascinating being able to run this building through PHPP in Strathclyde. It was even more fascinating when we found it was already Passivhaus. Once we tweaked the G factor of the glass, that's all we had to do. I think it might have cost us 500 quid to achieve it. This is the project overlooking an estuary, again exposed nicely to the south with excellent views down to the southeast. It's quite steep as sites go, upside down living accommodation with a basement below, which had its own issues and introduced us to hydrothermal issues that we needed to resolve. We also challenged the building regs at the time, because remember this would have been back in 2009, so we were based on the 2007 building regs, where you had to have a fixed amount of renewables. And from percentage wise, we really didn't need them. We were going to be dumping hot water. We actually got a waiver, which was really good, and fair dues to our local building authority. It's heated solely by towel rads and one rad in the utility room. The heat load is 9 watts a square meter. There is a post heater, but it rarely comes on. And we have underfloor pipe work, but it has never been commissioned. So the gas boiler that was installed in that house was purely really there for domestic hot water. It has a drying tower integrated with the ventilation system, and that's synonymous with most of our dwellings at this point in time. But when we found out it was meeting the Passivhaus standard, that was based on Dublin climate data, and there's a whole rigmarole. Many of you know we beat a lot of drums at the time that we needed more climate data files. We ended up getting 4 to include for Cork, and of course we do individual site climate files to get accuracy, because any of these software simulation programs, rubbish in is rubbish out. It's the floor plan. This is the lower floor, which is built into the hill effectively. You've got the plant room at the back there, with where number 10 is where the drying tower is located, and all the plants in that room. And then you have a common bathroom, master bedroom to the right, and then 2 smaller bedrooms flanking a communal area. That communal area would be, again, quite common in all our plan layouts. We use circulation areas for living areas as much as we can. This is the upper entrance level. You enter from the north through Passivhaus, even though we didn't realize it at the time, there's no windows really to the north. Everything is to the south. We had an interesting layout issue here where number 4 is where we had a multi-purpose room, which had a sliding screen, a folding screen on the southerly side, to enhance the upper deck area and to allow active use of the upper deck with small kids, because going from kitchens down to the lower garden areas wasn't really a runner when you had 1 and 2 year olds about. That room opened up completely and it was semi-covered. I'll show you some pickies of that in a moment. Your living area on the right, off which there was a study. There's an interesting room number 2, which is on the northeast of the house, gets very little sun and had a roof light because we were worried about the amount of light getting into the room. And that's known as the pastry room, even though it operates at 20 degrees like the rest of the house does. Surface temperatures in the walls were lower. So we learned something with that. We tend not to use roof lights now, if we can avoid it. Here again, you'll see the same old ding dong. We use stack ventilation. We incorporate in all our projects. It's really critical. And in this case, we stack up through that winter garden or the dining area. Big overhangs. And we had a double thermal envelope around that winter garden because we were concerned that the sliding door or the folding doors wouldn't achieve the airtightness results we needed. So we have a full airtight envelope on the interior as well. Some pickies are just dug out there. You can see the ICF in the basement and then the timber frame on top. Site wasn't always that messy, in fairness to them. And then this picture just shows a window, which is in the southwest corner from the kitchen. And that was designed not so much for solar, because remember we designed this building and planning well before we ever saw PHPP. This was designed to screen off the traffic that accumulates from Crosshaven coming up into this estuary area. On the right then you can see we've got our drying tower, which is on the extract zone. The extractor is way up top there, which is the last main extract into the MVHR. And here from the hall, treble glaze sliding door into the hall, and then more treble glaze units going out into the outside, which pull back and give this space, which is, we drive past this regularly, it's open all the time. It's open from March on. It gets very warm in there, and you can see we've got glazing up at high level. On the climate side, climate on the coast is very different. There's a coastal margin that one needs to be aware of. Very good solar access generally on the immediate coastal margin, but as the cloud accumulates inland, it prevents the solar access getting further across. And the sites, my battery's going low on my mouse. So I've just been told. Orientation, obviously critical. Generally, you want to be looking out on the sea. So sometimes that can cause difficulties in that there's a conflict between solar access and visual access. Stack ventilation works really well because you can cool off the sea. Another project some of you might see in early doodles for a project in West Cork. Here we go again. It's a letting it all hang out really. We went wild with the glass. We had an amazing site, but we also considered the overhangs very significantly and seriously. Even though it's our glassiest house, it's actually our coolest house in the summer. Stack ventilation built in the foreground there on the right is sunroom. And another interesting thing we include in most of our projects is water, which you can see down below, which is down in the corner there in the knuckle of the house. There's access from the common area on the first floor to terrace. And what was interesting for our stack ventilation, this particular project, is our windows, particularly our lift and slide units, all have this integral full height vent, which keeps the furries out, the wazzies out, the rain out, believe it or not, but allows the air in, and they're open generally quite most of the year outside the heating system or season. This is the plan form. Interesting plan layout. It's entered from the east. The rooms are segregated by a staircase rather than by doors. There are screens to meet fire regulations. Kitchens right down on the left there, which is on the way, taking the view, it's Roaring Water Bay, Kilcoe Castle, if any of you know it, straight out there. And then you have your dining, living area, steps up into the sunroom. All your plant rooms are on the north side of the house, and there's also a guest bedroom and a Jack and Jill bathroom. Number 7 there would be a little study tucked in a quiet part of the house. Upstairs then we have 3 bedrooms with again a communal living area, which is access out onto terrace, which is the most incredible views out to the fastness, etc. Stack ventilation, thought of and integrated from day one and really works. There's a temperature activated vent up in the high on the left there, which is on the lee side. It's on the northerly side, and generally the prevailing winds are from the south in these areas. And it just cools. The hotter it gets, the more airflow goes out through there. In fact, if you have the sliding door open in the kitchen area and it's a warm day, Marilyn Monroe would be appearing any minute. It's that windy. We used a lot of stick-built house. We used TGIs. We were introduced to thereby the steel is there. That's a Paralam, which is as strong as steel for the same sort of size and reduces thermal bridges. We had some issues. We had a shed that was supposed to have been built. On the left, you can see varying temperatures in a particular room, which is the bedroom. And in detail, we had an issue where we had a shed was supposed to be built, a roll top shed. It wasn't built. We were taking in far more energy in through the southeast than we expected. We looked at putting in solar films. They were ordered to be put on the outside, but they put them on the inside. And what we're measuring here is 32 degrees surface temperature of the glass on a hot day. So what was happening was the solar film was on the wrong side of the glass and was heating up. So be wary of that. We could have done more in relation to that once we knew the shed wasn't happening. We looked at our thermal bridges very seriously on that project. We did a number of different materials because we were building into rock. We got a Y factor for any of the nerds out there in BER terms of 0.0262. Again, all this Passivhaus just works within the architectural framework and idiom that we like to use. This is probably one of my favorite views in the house, which is looking up the stairs, up underneath where that cooling area is for stack. That's looking from the entrance down towards the kitchen with the living area on the right, and you can see you can mix old and new quite easily. And that's where you cook and watch your new prawns and mussels being brought into you. But the overhangs stop you overheating. Nighttime view. Again, you can see the water in the foreground. We introduce water wherever we can. It's really, as I said before, excellent for cooling, particularly nighttime cooling. And can do great things for reflections. I don't know whether this will fire up, but we'll try it. This was taken, this was taken during a Passivhaus open day. It would have been early morning, looking at where the sun's coming from. And that's this kitchen ceiling. Now that shimmer that goes on there has kept children, 1-year-olds active for 40, 50 minutes on the hop, which is really interesting. And it comes around and sets on the wall like a ball of fire in the living room. So you don't need a fireplace in a Passivhaus. I have to show you this because people would think I've lost it if I don't discuss climate. This would just show how two different buildings can perform. The building on the top with the HPI gold is a city Passivhaus, and then the one on the right, the one I just showed you, is down West Cork. And you can see heat load wise, heat load's very low in the robust city house. Heat demand would get up the country quite well, whereas the very glassy house wouldn't move up the country at all. There's about a 45% variation in energy load and energy demand over the country for a given house. These buildings need to be robust when they're on the coast. Just don't mind what they tell you on the warranties. In fact, don't mind what they tell you at all. Sometimes check it yourselves. You'll see the corrosion on a whole door handle. That's so-called secure by design, and also what Orphelia can do to a glass cantilevered panel, and more so to the stainless steel welding that failed. It's worth looking at. I was up in Cleggan last week and I noticed that rock in the top right there, just all on its own, looked a bit odd. Went over to have a look at it and you can see the force of the sea. Just lifted it out of it, which brings us on to one of our more recent projects. This is a site that we're working on. This is next door where they've got some reinforcement onto the cliff face. You can see the size of the stones thrown around. They also get thrown around over that fence up onto their lawn. This is the site. You can see again the concrete embankments were into the left of that. And this is our response. It's like a pavilion built into the hill where unusual roof. It's trying to keep low to stop interfering with views for people walking behind us. It's an amenity area, but this house is looking north, right next to this fort, which is a Georgian fort, and was extended over the years, but back into the 1900s with the Navy at the time. And you can see there's rather lovely warmth in the concrete piers, jetties, and embankments. We tried to match that. Started looking at how we would do it as we built into a hill, and found that materiality was going to become an issue, and it wasn't just Passivhaus, it was NZEB or anything you want, but our Passivhaus experience and knowledge was able to steer us as to how we could achieve a really high performing basement for a north facing house with very little solar access and yet not get condensation. This is just a render we took yesterday off our bin model. And you can see the overall form. You can see I can get my pointer, maybe, if I can. No. Okay, failed miserably. Anyway, this is the terrace on the west-hand side, which is getting sun from about April, and really important. The roof covers that area, shelters it in the evening from dew, which can be a real issue near the coast with clear skies. You've got living accommodation down or on the upper floor, and bedroom accommodation primarily down the lower floor. Bear with us, sorry. Okay, I have an issue here, just bear with me. Ah. Okay, we're back on. This is the back of the house. We tried to minimize any interference with the cliff face and the trees. There again, you can see that western terrace. Cross section through the house. We've a solar PV array, which is getting PV power over the carport area. It's a site plan. Plan form, rather unusual, would be the entry level. Again, living accommodation looking to the north, very limited solar access. So very robust performance. This achieves a BER of A1, EPC 0.195. It's actually got a heating load of 8.11, but the demand is much higher than we would normally do. Not that we're too concerned about it, it's about 23. Lower floor level, again, bedrooms, communal space, and plant rooms tucked into the hill. It's a section. Views, and again, view down onto the cliff. It's on site. We have 70 piles in the ground. Rather complex insulation then on top of that, with membranes on top of that, and slab, and then another insulation layer. It's the only way to get around the thermal bridges. Lots of concrete. We managed to get GGBS. The embodied carbon reduction was 23% for the concrete alone by doing that, which saved us a significant amount of equivalent carbon, 12,540 kg indeed. When we worked all that out, it was actually the equivalent to 9.5 years of operational carbon, which was offset by a change in the concrete spec. So you need to look at that. It's another house that's on at the moment on site. Site has begun, raft foundation. It's actually very close to the other Roaring Water Bay project down near the pier, longhouse with again, orientation and form factor not ideal from a passive house, but we can get away with merger down here in Cork because it's so mild. This is the dwelling. Upside down again, access views. And we've got a Y factor there of about 0.022, it's timber frame. Another one, which is near the first one I showed you along this area. It's in the center of the photograph. Early doodles. So you can see the low energy stack ventilated project we did in 2003, which is up in the top right. And then the center is a new dwelling. And then there's a really nice arts and crafts house to the left, and the architecture was responding to that. Again, the river's on the right, which is to the north, and we wanted to get access, view over the northern part and all the activities on the river. This area is now pedestrianised. Got a courtyard plan form, again, not great from a form factor perspective, but brilliant for getting light in to the core of the building, particularly to the northern sides of the building. We've got a living accommodation on the left-hand side there, courtyard in the center, kitchen, and then on the northeast utility area with, believe it or not, a drying tower. And then on the upper levels, again, bedroom accommodation, study on the north, terrace there at number 2, overlooking the river. And we have an interesting concept, which is for grandchildren and kids, where they can have bunk beds and 4 people can stay in that room, and that suite effectively on the right-hand side, rather than have a series of individual rooms. It's just a cross section through the courtyard, which we'll be using for stack ventilation. And that would be a full 3D render of the back of the house. Again, form factor is not pretty, but again, it's quite mild down here, and we're not having to go OTT in relation to building energy or envelope performance. It's very influenced by the property that we did to the right with the larch and the sloping and raking zinc roofs. And then we're picking up the property on the left, the arts and crafts building, with white brick clad screen system. Again, all timber frame. This image is from another one of our cycling trips. Is down Dingle last year and sums up the constraints and opportunities that are encountered really in coastal locations. We're there for the afternoon, and it was more or less like this for the afternoon. 4 seasons in one photograph. Milder temperate location was influenced with the beach and the sun for 3 hours, and cloud and rain to the west, which is only 1 kilometre away. Add in maybe a 60-metre, 80-metre lift, and you're in a completely different climate. We found that the large volumes that we use absorb and dissipate the heat. You get enough air, but not heat distribution through a 15-millimetre gap at a door in cellular arrangements. All our buildings have to cater for the fact that it's a hostile environment with severe winds, driving rain, corrosion potential, as I showed you. And the envelope components, they must meet the aggressive criteria that they're subjected to. The delivery on the coast is not just about thermal, it's about weathering and many other factors. I suppose Passivhaus performance needs to acknowledge the desire for sea views, which can impact on building orientation. So you can't always just have no windows in the north, as we showed you there in that pavilion type concrete building. Airtight standards yield real results, and the Passivhaus levels and some of the levels our colleagues are achieving really help in this regard. Temperate climate will permit large areas, glazed areas, once a solar control strategy like we did in that Kilcolleen house and with the deep overhangs is employed. And stack ventilation can address overheating. It's the only thing that really can, in my view. So we keep the heat load low, and then the comfort can be achieved. I suppose to conclude, I need to say that our amazing clients entrust us with these projects and allow us to experiment, monitor, and log for what appeared to be lifetimes. The Carrigaline Passivhaus, there was a kid born during the project, and I think running around now 12-year-old, and have all become eco warriors, which is fascinating. But our team at WMA continue to excel, question, and they all hone their skills at all ages. Our consultants, contractors, suppliers, they all engage enthusiastically as well in ensuring the right balance of design, science, cost control can be delivered. I think Passivhaus is here to stay, and our temperate coastal environment is easy to achieve it without any compromise in delivering future-proof buildings or compromising architecture in any way. And that's me. I'm done. Thank you.
Thanks very much, John. I think it's safe to say some beautiful projects, some great clients, and but I think clear that your journey, which started before your Passivhaus qualification, was already based on an incredibly thorough understanding of the context that you're working in and lots of the issues, being able to achieve that standard pretty much before you'd even really get stuck into it. So that's great. There are a couple of questions I did forget to say at the start of this to stick some questions in the chat. There are a couple, and if anybody else has any, please pop them in and I'll try and pick them up. The first one was from Tomas, and I'm not sure which building it was referring to, but he was just asking for a reminder of how you achieved the airtight connection between the window frame and ICF.
Yeah, we raised it. Yeah, it does. We raised it at the time. We didn't believe you could get an airtight connection because you're connecting to polystyrene blocks, which are all connected and joined together. So what we did was we connected back to the concrete and then put back in the concrete or the ICF EPS.
Thanks, John. Question from me. I was just wondering, you referred to site-specific climate data, and I just wondered what's your experience of, say, the most local area or regional climate data, and then where you've gone for site climate data, what kind of variations are you seeing in heating load or heating demand, for example?
In say even down in Cork alone, and anyone local would know, say difference between getting site climate for say Glandore or Garnish Island or one of these places down West Cork, which are very, very temperate, to say Watergrass Hill or Rathcormac on the way up the Dublin Road, for anyone who knows it, which is usually icy in the winter. About 45% difference in annual heat demand. It's massive. It's very significant. The worst I've ever come across was the difference between Westport and Newport, all over a hill, a mountain range, you know, and lack of solar access. So it's fascinating. The sad side of it all is we're very lucky in that we've been doing climate data now for 10 years after we got embroiled in a discussion over it with the ONB Passivhaus. We decided we'd take it on and look into it and do it ourselves. And a lot of the Passivhaus community here and abroad have supported us in that we maintain delivery of site-specific climate file. But we're noticing about a 1.5 degree change from when we were using, say, the 1990 climate data set, which isn't that long ago, to where we are today, which is using, say, the 2019 and back climate data, particularly from a temperate perspective. So it's, global warming is definitely happening. We've even noticed the CO2 monitoring we've been doing down in Onabwee. We've seen that rise and go up through 400 over the last 10 years. So it's fascinating having all that monitoring available now.
Indeed, John. I think it's clear your designs, and you kind of alluded to, you know, not the ideal form factor for Passivhaus. I guess Passivhaus gets hammered for producing, you know, boxy, dull buildings, and you know, certainly I'm an advocate for doing something different, and it's great to see, you know, that you are acknowledging you've got the benefit of the local climate. But you know, have you had to compensate much in, for example, the wall U values or anything else to achieve that, or have you been able to do that with pretty much standard Passivhaus values?
Pretty standard. I mean, the Carrigaline Passivhaus, I think it was in the slide back there in the cross sections, showed what the U values were. They weren't extreme, and we were using good quality windows anyway. I suppose you could argue back then in 2007 why would we be using treble glazed units, but we'd have certainly been using double glazed units. And I remember our QS, who's been with us all the way along our Passivhaus journey, calculated, I think it was 3.84% rise on achieving Passivhaus compared to conventional builds at the time, to the standard we were working at. And I think you have to admit to that. But those buildings have proven themselves, that some of them, you know, they're 10, 15 years old, and they're still cutting NZEB.
Yeah, Tomas was just asking, yeah, anything you could share on construction costs. So I guess you kind of you know, just covered that off, which you know, with that percentage, which would you know, is given the range that you see talked about for Passivhaus, is certainly at the lower end of that scale in terms of an uplift. So that's really interesting.
Yeah.
Okay, let me just see if there's any further questions. I guess maybe one which is drawing on your experience over a period of time, and you know, clearly your own work tells a story, but just interested to hear your view on, you know, the wider industry and how far or you know, how far we've progressed, or maybe how little we've progressed. Maybe is the question, but just your view on where we are and where we sit right now.
I think the argument for pushing Passivhaus is there. It's gone. It doesn't need to be made anymore. It's proven itself. I think we've been lucky. Again, we're quite lucky down here in that we've a lot of, I would say, foreign clients who have seen what levels of comfort can be delivered at reasonable cost and demanded down here. We've a lot of that, and as a result, we've ended up with, you know, being able to get access to materials over the last 10 or 12 years with our local suppliers. Are seeing these coming in all the time locally with Paul McNally, ourselves, and Gareth, and there's quite a few of us down here working away. We can get all these products. They've become very standard now at this stage. Most of the contractors have been touched by it, and none of them go back after they've been touched by it. They all want to stick with it. So I think it's, I'm worried with NZEB in that it's very easy to achieve with renewables. The focus on fabric seems to have taken a step backwards with NZEB, where it's going, and I'm hoping that'll readjust as we hopefully we won't see too many issues with lack of comfort, etc. Asking for a government level review of NZEB and how it's being implemented. I think the next step now is, and Passivhaus can be delivered very easily. I think it's being carbon compliant from here on in. That's what we need to look at, and being carbon responsible as designers and deliverers of buildings.
Indeed, indeed. Okay, thanks, John. I'm going to just finish the Q&A there. There are a couple more just popping in last minute, so next time everybody needs their questions in much earlier, but we will try and answer those offline for those that have just asked them. We're going to go now to the breakout rooms. So as Barry said, please hang around. It's very informal. We just get to know each other, have a chat, and then we'll all come back together to close out. So Yvonne, if you can shunt us all over into the
sure.
breakout rooms.
Just about to do that. Thanks.
Okay, so it's all been handed back to me now. I have to say that was very pleasant. I met two people I never met before, so it really delivered. And unlike last week, I wasn't put in with a member of my own team from work, so really enjoyable. Okay, so it's up to me to provide a wee bit of a snippet ahead of Passivhaus news, or what's going on in the ether among this lovely community that is Passivhaus. And this week it really is just to let you know about the Passivhaus summer days. They are on the 25th and the 26th of June. So that's a Friday and Saturday, and there's two projects in Ireland. The first one is Donald Cassano, who I think is actually on the meeting as well, and his project is in Cork, and it's going to be via Zoom. So you'll get the details now. I'll post them in the chat here before we finish off. And the other project is an in-person project, which is located in Dublin 6, and it's an ongoing Enerfit project. And on the 25th, the Friday, there's a tour at 2 p.m. and on the 26th, there's a tour at 11 a.m. as well. And I think the owner is on the call as well. So welcome to them. It's great to have you. So people should check out those projects, and I'll post that in the link now. So now it moves back to Simon, who's just going to give an overview of the next event and what the content of that's going to be.
Okay, thanks, Barry. Technology. Yeah, so yeah, the next event will be on the 1st of July. This is going to be the last event ahead of our summer break, and then we'll be picking up again in September. So on the 1st of July, really interesting project, and I think a little bit different in terms of its scale. It's the first Passivhaus premium project in Ireland, and you know, they are encompassed. The future of education is the title of the presentation, and Barry will be giving us that, and I'm sure there'll be lots to learn from that project. So really interested, and I know people across Ireland, UK, and indeed the world will be looking at this project. So really excited to hear about that. Just before I hand back, Barry, there was also a question. I've just been handed a question from the breakout rooms about the previous presentations. So all of the previous presentations are available on the PHAI website, and this evening's presentation will be there in a few days' time. They're there for a period of about 30 days to anyone who's registered. But after that, then they'll become a members only resource. So another great reason for joining the Passivhaus Association of Ireland. So that's it. I'll hand back to you, Barry.
Yeah, very good. So it's really just handing back to me, I think, to bid you all a good night. And thankfully, I suppose I should give a nod to our speaker. For me, I have to say it was absolutely fascinating to get such a medley of projects from John, and it really does chart, like the previous two events we had, the personal journey and the education that's gone along with it. So a really good event all around, I think. So just on behalf of the team, I think we're all being put together. Maybe it's not just going to be me to wave you off and to round out for this evening. So thank you everybody for coming, and hope you can make it to the event next week and not off too much by myself. So look forward to having you on the 1st of July at 7 p.m. Okay, and we'll talk about the Iron Campus then. So okay, that's us for tonight.
Bye everyone.
Very good.
Cheers.
Okay, that's us, isn't
Just
it?
ourselves now.
That's okay. We can stop recording, I think. There's always a little bit more to learn.